Hello and welcome. Today we are going to have a primer on coordinate plane geometry and learn a little bit about the distance formula. Um, so let's start with some definitions. Point. A point is defined as a location in space that has neither length, width, nor depth. Points are normally represented as dots on a line or a graph and named with capital letters. So here we have just a couple points. All right, let's move on to the definition of a line. A line is an infinite set of points extending infinitely far in opposite directions. Array. Array consists of a point and a half line. It extends infinitely far in one direction. And then a line segment. A line segment consists of infinitely many points between and including two endpoints. And then we're going to talk about collinear points. So basically, collinear means that they exist on the same line. Points are collinear if they lie on the same line. And then we're going to talk about another concept of betweenness. Another undefined concept in geometry is betweenness. If 3 points are collinear, then one of them is between the other two. Lines can be named with a single lowercase letter, like line L. For example, we could call this line L. All right. Or with two capital letters that represent points on the line. For example, line AB, and that's written capital A, capital B, and then above it would have arrowheads on either side. Is the line containing points AB. So if we wanted to call this line AB, we would just simply say AB. Okay? All right. Array is named with two capital letters. Ray AB, or capital A, capital B, with the arrowhead pointing toward the B, contains the points A and B, where A is the endpoint of the ray and B is a point on the ray. So we could change our line into ray AB just by simply erasing this part. And so that would be called ray AB. We would start with A, point A, and it would go through B and infinitely far past B. Okay? Next, we're going to talk about a line segment. A line segment is named with two capital letters and has measurable length. Line segment AB, or capital A, capital B with just a bar above it, has two endpoints A and B. So now we'll turn our ray into a segment by simply erasing this part of it. And so that would be line segment AB. It would start at A and stop at B. Okay, all right, let's move on. That we have some definitions in place. Let's talk a minute about the different types of angles, and then we'll introduce the distance formula. Okay, so here we have some angles. The small one here is called an acute angle. Acute angle is less than 90 degrees but greater than 0 degrees. And then up here we have a right angle, and it measures 90 degrees. And then this little box looking thing, it indicates a right angle. So anytime you see that in geometry, you know that's 90-degree angle. Okay, the one that's opened a little further past 90 is called obtuse. Obtuse angle is greater than 90 degrees. but less than 180 degrees. And then right here we have a straight angle, and a straight angle has a measure of 180 degrees. So we could just imagine it going from here to here is 180 degrees. Now in this resource it does not talk about reflexive. So a reflexive angle is actually larger than 180 degrees. Okay. Now we're going to talk about the distance formula. It says, notice that a subscript added to the x and y identifies each ordered pair uniquely in the plane. For example, point 1 is identified as x sub 1, y sub 1. Point 2 is identified as x sub 2, y sub 2, and so on. This unique subscript identification allows us to calculate slope, distance, and midpoints of line segments in the plane using standard formulas like the distance formula. To find the distance between 2 points on the Cartesian plane, use the distance formula, which is d equals the under the radical y sub 2 minus y sub 1. All that quantity is squared plus x sub 2 minus x sub 1 quantity squared. And they want us to find the distance between these 2 points. So we can go ahead and label them if you wanted to. X sub 1, y sub 1, x sub 2, y sub 2. So we'll go ahead and plug it into our formula here. So under the radical, we have y sub 2, which is negative 4, minus y sub 1, which would be minus 1. And that quantity is squared, plus x sub 2, which is 3, minus x sub 1, which is negative 2. And then that quantity is squared. So that's going to equal, under the radical, we have negative 4 minus 1, so we have negative 5 squared plus, so this is going to be 3 minus negative 2. So minus negative is going to be plus. So it's 3 plus 2. 3 plus 2. So that's going to be a 5. And that quantity is squared. Okay? So that's going to equal, here we have negative 5 times negative 5. Negative times negative is a positive, so we have 25 plus 5 times 5 is 25. So we can put those together. So under the radical we have 50. 50. Now, what we're going to do with our 50, distance equals 50, we'll rewrite it. 50 can be broken down into 25 times 2. So now we have the square root of 25 times the square root of 2. And we know that the square root of 25 is 5. So our distance is going to be equal 5 square roots of 2 in whatever units they have. So we'll just call it units. Okay. All right, let's go on to some of these examples here and find the distance. Use the formula, and I just rewrote it as distance equals delta y squared plus delta x squared. If either way, it's the same formula. So let's take our distance equals the square root of delta y. So if we start with negative 9, we would minus negative 2, and that quantity is squared, plus, if we started with negative 9, we must start with 3, minus 8, and that quantity is squared. So now we have, under the radical, negative 9 plus 2. Negative 9 plus 2. Well, let's see. Negative 9 plus 2 is going to be negative 7. Negative 7 squared plus 3 minus 8 is negative 5. Quantity squared. Okay, so under the radical, negative times a negative is a positive. 7 times 7 is 49. Plus negative times a negative is a positive. 5 times 5 is 25. Okay, so now we have 49 and 25. So that's going to be 74 under the radical, 74. And 74, I don't think we can do anything with 74. So our distance is going to equal the square root of 74 units. Because we can't break that down any further. Okay, let's go into this example really quick. So distance equals delta y. If we start with negative 1 minus 6, that quantity is squared, plus, we would have to start with 1 minus negative 3, and that quantity is squared. Okay, so here under the radical we have negative 1 minus 6, negative 7 squared, plus 1 minus a negative, so that's plus 1 plus 3, so that's going to be 4 squared. So here we have negative 7 times negative 7 is positive 49, plus 4 times 4 is 16. Alright, so now we have 49 and 16. So now we have 65 under the radical. 65. So our distance is going to equal square root of 65 units. And 65 has to stay under the radical. There's nothing that we can bring out. So hopefully that's helpful to you. We've learned to work the distance formula. We've learned some of the terminology associated with coordinate plane geometry, and hopefully that's a nice primer for you. Thank you, and we'll see you on the next segment.